Okay, hi everyone. My name is Kyson, and today I'm going to be walking through 1994 Step 2, Question 7. A really wordy question. So let's get straight into it and let's not waste any time. Okay, the first part is, I think, is fairly fine. Okay, so all you need to do is we factorize out this a here, and then we just complete the square on both of these brackets. Okay, and the keynote here is that dividing by a is allowed since we're given in the question that a is greater than 0. Therefore, a is not 0, which means that we can divide by a. Okay, so then we come down here, and then we have this circle with this center and this radius. Okay, I don't think there's anything too difficult there. So let's move on to the next part of the question. So let's have a read of this question, because I think reading is very crucial for this question. We need to understand what's going on. We're going to do some drawings and we're going to try and understand what the question is actually asking us to show. So we're given that the smooth and level parade ground of the first Ruritanian, I don't know how to pronounce it, guys, Ruritanian, I think, infantry division is ornamented by 2 tall vertical flagpoles of height h1 and h2 and distance d apart. As part of an initiative test, the soldier has to march in such a way that he keeps the angles of elevation of the top of the flagpoles equal to one another. Interesting. Okay. Show that if the 2 flagpoles are of different heights, he will march in a circle. What happens if the 2 flagpoles have the same height? So that sort of second paragraph there is kind of split into 2 questions. Okay, so it's different heights, so he traces a circle, and then it's the same height. We don't know what happens. Let's have a think about what this diagram is going to look like. So we have a soldier, and it says that he needs to walk in such a way that he keeps the angles of elevation of the top of the 2 flagpoles equal to each other. So if we have our soldier here, and then we have our flagpoles here and the flagpoles here, he needs to keep this angle at each one the same, all the way along his walk. And apparently that traces a circle. So it's going to look something like this. Okay, so we have our soldier, who's here, and then they're walking along this path in such a way that they keep the angle of elevation between the top of flagpole of height h1 to the top of the flagpole with height h2 equal. Okay, so that's kind of what the situation looks like. Now we can model this situation in a 3D coordinate system, and that would look something like this. Okay, well, we have our soldier here at a general point xy. Okay, and for simplicity's sake, we're going to let the flagpole that is of height h2 be perpendicular to the y-axis, and we're going to let the flagpole of height h1 parallel to the z-axis and along the z-axis. Okay, so this means that the xy plane you can imagine as the ground floor. Okay, and then we have our person here, our soldier, who is on the ground floor, and they're going to traverse some circle. Okay, so now in order for this angle and this angle to be the exact same, now remember, these 2 flagpoles are of a distance d apart. For this angle to be the exact same as this angle, that means tan theta of this triangle has to equal tan theta of this triangle. But then if we draw that left triangle, we have square root x squared plus y squared. and h1 and theta. That means tan theta is simply h1 over square root x squared plus y squared. And similarly, for this triangle, we have tan theta equals something similar, but this time it's h2 over x squared plus, now remember, this distance here is d minus y. And then if this length here is x, and this is d minus y, that means this length here is square root x squared plus d minus y squared. Okay, so that's where we got that length there. That means tan theta has to equal this, which means this has to equal this. So now we set the two of them equal to each other, and then now there's just a lot of algebra, but we can see that this actually does trace the arc. This does trace the path of a circle, okay? Now, I want to point out something crucial in the algebra here, because we're going to return to this equation. There is a part where I divide by h1 minus h2, h1 squared minus h2 squared, sorry, and that is allowed since the heights are different. Okay, so h1 does not equal h2. Therefore, h1 squared does not equal h2 squared. Therefore, this thing does not equal 0. So I'm allowed to divide by h1 squared minus h2 squared. So if you take a look at this algebra, similar ideas here. Just be careful with the completing the square. You need to make sure that you factorize out. When I'm here and then I move on to this line, that's because, can you see that when I multiply this bracket by the h1 squared minus h2 squared by the y squared, I end up with this term here. And then the h1 squared minus h2 squared multiplied by this gives me the minus 2h1 squared dy, which is what I need. And this dy here is not to be confused with anything to do with differentiation or integration, anything to do with calculus there. So, yes, so we have this circle here, and the soldier must trace the circle with center 0 h1 squared d over h1 squared minus h2 squared, and the radius we don't really care about, but that's there as well. So let's move on. Now, if we go back to the question, it asks what happens if the two flagpoles have the same height? Well, if the two flagpoles have the same height, if we return back to this line of algebra here, which I said was going to be very important, okay, and then we set h1 equal to h2 squared, can you see how this term becomes 0, this term becomes 0, and then we're left with this equals this. So we're left with minus 2h1 squared dy is equal to minus h1 squared d squared. I can divide by minus 2. So I have h1 squared dy is equal to h1 squared d squared. And I can divide by d, and I can divide by h1 squared. And that gives me y equals d over 2. Now that's interesting, because that is simply a straight line that is the perpendicular bisector of the line between the flagpole of height h1 and the flagpole of height h2. And that can be seen here by this lovely diagram. Okay, and that makes perfect sense, right? Because now these triangles are the exact same. Well, if these triangles are the exact same, then can you see how this distance must be the same as that distance? And if he keeps moving along this line, no matter where he is, because this height is always the same, and this path, this line here, these two lines are always equal. Wherever the soldier is, he's always equidistant from this point A and this point B, which means that tan of the angle will always be the same as long as he's along this line. Does that make sense? So if we visualize him walking down here, since that length is equal to that length, and this length is equal to this length, that angle will always be the same. Okay, a very interesting question there, but a result that I think is quite intuitive once you've drawn the diagram. Okay, so now it gets a little bit more interesting. So it says, to celebrate the king's birthday, a third flagpole is added. Soldiers are then assigned to each of the 3 different pairs of flagpoles and are told to march in such a way that they keep the tops of their 2 assigned flagpoles at equal angles of elevation to one another. Show that if the 3 flagpoles have different heights, H1, H2, and H3, and the circles in which the soldiers march have centers xij, yij for the flagpoles of height hi and hj, relative to Cartesian coordinates fixed in the parade ground, and then the xij satisfy this long equation. That was a tongue twister. Let's slow down and let's think about what the question is asking. So again, I love diagrams, you should love diagrams. Let's draw a diagram. This is something like what the question is asking. Now, interestingly enough, if we carried on reading, we would have had this idea to use Cartesian coordinates to ground the problem up here. So maybe it is a good idea to read on in questions and kind of see if reading on gives you any hints, because you might not have thought, okay, well, if I have this situation here, immediately I need to ground it in Cartesian coordinates. Reading on could be something very useful in the fact that questions might give you hints later on in the question. Okay, so let's have a look. So we have this situation here. Now I've labeled this length here D1 and this length here D2, and we have our same setup as last time with our 2 flagpoles, but now we've just added a second flagpole, and for simplicity's sake, I'm going to make the second flagpole perpendicular to the x-axis. Okay. Now, if you spend some time long and hard thinking about the different lengths, okay, of each of the triangles that we're getting, we're going to have 2 triangles for each circle. So we're going to have 3 equations for tan theta. Okay, does that make sense? So if we go back, H1 and H3, so that's looking at H1 and H3, that's looking at this triangle here and this triangle here, and saying that tan theta is equal to this equation here, and then doing likewise for the other 2 circles. So now we do exactly the same thing as we did in the previous part. Remember, like I always say, part n always helps with part n plus 1. It's just that the algebra is going to be a little bit trickier now. So after you do the algebra, for the first equation, we have this to be our x31, y31. And then for the second equation, we have this to be our x12, y12. And for the next equation, we have this to be our x23, y23. So now we have our xij, yij. And as you can see, the algebra is quite long. However, if you could do the first part, you could definitely do this part. My advice is to really slow down and really go through the problem and make sure you're not missing any steps. So let's move on. So now we need to show that the equation holds. So we're going to substitute our x12, y31, and x23. So substituting that in, remember our x31 is 0, so this term becomes 0. Our x12 is h1 squared d1 over h1 squared minus h2 squared. Now, I have a h2 squared minus h3 squared here, but I have a h1 squared minus sorry, I was looking at the wrong one. Yes, so this is looking at 2, 3. Okay, so 2, 3, and we're looking at x. Okay, so I have a minus h2 squared d2 over h3 squared minus h2 squared. Now I can write that as minus h3 squared minus h3 squared, no, h2 squared, sorry, minus h3 squared. and then keep the minus at the top so that these two can cancel out. But then this minus minus just makes a positive. So now I have h1 squared, h2 squared d2. And then similarly with the 3, 1, we have, if we remember, that our x31 was h1 squared d2 over h1 squared minus h3 squared, substituting that in, but our denominator is different to up here, so we're going to put a minus sign so that these can cancel. Okay, so we end up with this, which is something minus that exact same thing, which gives us 0. So the left-hand side equals the right-hand side, therefore this equation is true. Now they didn't give an equation for y12, y31, y23, but we're going to conjecture by symmetry that this is the equation. So all I've done is I've essentially swapped the x's for y's. Okay, I've swapped the corresponding x's for y's. And when you do that, again, you just substitute in the points that we were given, you find that it does, in fact, equal to 0. Okay, so now for the last part, we need to prove that the centers of the circle lie in a straight line. This is actually, in principle, easier than you might think. So if we want to prove that 3 points lie in a straight line, we need to prove that the gradient between this point and that point is the exact same as the gradient between this point and that point. Okay? Because that means that you have the gradient of a straight line that passes through the exact same point and connects all 3 points. Does that make sense? So if we have a look at this equation here, what is the shared point? Well, it's x12, y12. So if we prove that this left-hand side is equal to this right-hand side, that these gradients are equal, we've shown that those 3 points have to lie on the same straight line. So again, the algebra is quite long, but if you do it, you find that these two things are the exact same. Okay, so be very careful with the algebra here. So here this becomes a positive, and then remember our KFC, keep flip change, with our fractions. I'm going to bring this up, but I need to flip the fractions, so I get this. Okay, I see that this cancels with this, and then we have this expression here, and then it simplifies to this here. And then likewise, this one's a lot easier. You might have to take out some minus signs so that things start flipping, and then you can do some cancellations. Yeah, so that means the points must be collinear and therefore form a straight line. So a very, very hard question here. If you can do this in 30 minutes, then fair enough, you are a brilliant mathematician. If this took you a while, don't worry, it's a tough question. I think the main takeaway from this question is to draw excellent diagrams and make sure you understand the wording of the question and really be thorough with your algebra. Okay, so I hope you guys enjoyed that one. See you guys in the next one.